A manhole cover looks like a simple iron disc until you ask why cities keep choosing the same shape. The popular answer is that a round cover cannot fall through its own opening. That is useful, but incomplete. The full answer connects geometry to weight, traffic, water, maintenance, and the frame hidden under the street. Begin with width. Engineers can measure a shape between two parallel lines that just touch opposite sides. Turn a circle to any angle and that distance never changes. Every direction gives the same diameter. This property is called constant width, and it creates the cover's most famous safety advantage. A circular frame supports a slightly larger circular lid on a ledge called the seat. Because the lid has no narrower orientation, rotating it does not create a direction that slips through the opening. That statement assumes a correctly sized, intact cover and frame. Geometry does not excuse bad fit or damage. Now compare a square. Its side is shorter than its corner-to-corner diagonal. Tilt and rotate it, and the clearance it needs changes. A poorly constrained square lid has a vulnerable orientation. Square and rectangular covers can still be safe, but their frames, restraints, and dimensions must solve that different geometry. Circles also remove a small operational nuisance. There are no corners to line up with the frame. A crew can approach from any direction, turn the lid, and lower it onto the same circular seat. On level ground, a heavy circular disc can also be rolled on its edge instead of carried flat. Heavy is not an exaggeration. One federal drawing lists about 38 kilograms for the cover alone. Its frame is about 39 kilograms, turning the visible lid into 1/2 of a substantial street assembly. That mass helps resist casual movement, but official designs still add seats, skirts, collars, and materials. Look beneath the disc and the shape becomes a cross-section. Cover, bearing seat, frame, collar, and concrete structure. Traffic pushes down on the cover. The seat spreads that load into the frame instead of balancing it on one point. The frame then transfers the force into the surrounding collar and pavement structure. Some municipal standards machine the matching surfaces to create a true, stable bearing. Some highway standards specify gray iron, minimum mass, and a recognized traffic loading requirement. In other words, the circle is not floating over a hole. It is engineered as a loaded joint. Repeated wheel loads introduce another problem. The lid must stay centered instead of walking sideways in its seat. Idaho's standard drawing answers with an anti-shift skirt extending below the cover seat. The skirt does not replace the circle. It controls a different motion that constant width geometry never promised to stop. Then there is water. A sewer access point sits exactly where rain and street runoff can collect. EPA guidance identifies open pick holes, poor fits, cracked lids, and deteriorated frames as inflow paths. So a cover must balance access for workers against an unwanted shortcut for stormwater. Workers still need a way to move the lid, which is why drawings include slots, notches, or pick holes. Albany's detail specifies a pick hole without a through opening, explicitly to reduce water entering below. A tiny feature can therefore reveal the system's trade-off: grip from above, protection underneath. The word manhole can also hide what the opening actually serves: sewer, drainage, power, or telecommunications access. Different owners and locations change the load, sealing, locking, and ventilation requirements. That is why the safe answer must describe a family of engineered covers, not one universal object. And not every manhole is round. Maryland's Highway Index includes square manhole structures alongside circular frame standards. Large or specialized access points may use rectangular, segmented, hinged, bolted, or otherwise restrained covers. The right shape follows the opening, equipment, load, access method, and local specification. Even constant width does not belong only to circles. A triangle can keep the same width while it turns. So why do streets not fill with triangular lids? Constant width is only one design requirement. The circle adds complete rotational symmetry, simple turning, a familiar round seat, and no preferred alignment. A cover also has a life after installation. Crews inspect it, lift it, replace it, and watch for rocking or damage. A cracked lid or worn frame changes the system, even when the original geometry was perfect. Maintenance therefore protects the fit that the elegant circle argument quietly assumes. The most dangerous moment may begin after the cover leaves the frame. OSHA requires a removed opening to be promptly guarded against a person falling in or an object falling below. Underground work can add atmosphere testing, barriers, attendance, and confined space procedures. The lid is not the safety plan. Return to the street and the design hierarchy is now visible. The circle controls orientation. The seat controls support. The material and frame control traffic loads. The skirt controls sideways movement. The pickhole detail and fit help control water. Each layer solves a different failure mode, which is why no single slogan can explain the whole object. So why are manhole covers usually round? The circle is safe to rotate, easy to reseat, and practical to handle. But it works because a real engineered frame gives that geometry a bearing surface, restraint, and load path. The ordinary disc is really the removable roof of a carefully underground doorway. Its shape is memorable. Its hidden system is what makes the shape useful. Subscribe for the hidden reasons behind ordinary things, including why shipping containers wear corrugated steel walls.